if I am live. Nope. Nope. Whoa, 9 seconds. Did I? Hold on. That's not right. Oh, okay, there we go. Oh, okay, there we go. Oh, that's low delay. Oh, that's low delay. Nice, okay. I can close that. Oop. Wait, am I? Discord is dying, so I can't send out the thing. Alright, let's check my dashboard. And Discord's dead, okay. Nice. Gonna have to wait a bit, I guess. That's my dashboard. Alright. Oh, there we go. Hey, that's one person in chat at least. Let me post my link in usual places. Okay. Should get some music going. Let's see what genre. Let's go for me. Okay, let's move this here. See, this is all right. That's piano, right? Yeah, let's not do piano. Yeah, that works. Sure. I don't know. Yeah, I should be fine. Alright, let's go. So, how long have you been live for? Like 3 minutes? Okay. Should be good enough. So essentially what I'm working on is the equivalent of matcher for Java. Make myself louder. I can't make myself louder. I can increase the gain on my microphone, but that's not gonna sound great. Let's see. So how's this? Is that good? Oh. Alright, there we go. Sure. Let's see then. GitHub. What was it? Fabric MC. And then Matcher. So what Fabric has? So Fabric is like Forge, like Minecraft Forge, except like new and better and stuff. They have this thing where they can create like source mappings for one version of Minecraft and then transfer it to the next one by comparing the binaries, which allows them to have like mappings for like basically any Minecraft version. If I can find them here. Wait, is it yarn? Yeah, it's yarn. So basically they have like this, right? Just files like this file has this name, you know. It's that's basically what they do. And I want to have the same for .NET, because I have a binary of which I knew the symbol names once, and then they updated, then I can't get symbol names anymore, and I basically want to port them over. So doing something like this, like making this kind of mapping file for one version of the game, or for one version of the binary, I mean, and then basically moving it to another version. That's what I'm trying to do. And so for that, basically, so just have a tool like pass in two binaries, read them, and then try to make trying to find like the same classes in both of them, right? Like if it's two versions of the same binary, but they both have like for instance, say you're reverse engineering a VM, you map the VM in one binary, like, you know, this is like the instruction executor or whatever, this is this instruction, this is something else. This is gonna help you port those names over to a new version of the binary or a new version of the VM. So let's see. So you make space capacity 2 modules. It will find matches basically by comparing types to each other. And if there's one type with like these fields, another type with exactly the same fields, and there's only like one match like that, you can be pretty certain that it's like the same type. So that's basically what I do here. So I have like a bunch of unmatched types, all the top level ones. I'm gonna turn this down because that's loud for me. You have a bunch of top level types. For each of them, you're gonna compare to the other binary, see if it's like possible match, which is implemented like this. You take the type attributes, then you check if there's the same amount of fields, properties, methods, inner types. Then check if like the type is the similar type, which is actually not required here because it doesn't do anything. Yeah, it checks all the fields, like are the fields a match, for instance, right? So you're gonna check like are the attributes the same and is the type the same. Same for methods and inner types and all that stuff. I am missing events, but I'll add those later. Yeah. And then after that, basically we check is there only one, then we see if we do a more like deep match that checks more things. Checks if we're 100% sure that it's the same thing. Like we didn't find anything different, then we just make it a match. We add it to our matching registry or whatever. And has some statistics, blah blah blah. And then we return the statistics here. And then we do auxiliary matches, which is something I implemented yesterday late at night. Which is basically you loop over every type. And for every type, you're gonna see if you can. Hold on, what's it doing? Okay. You're gonna try to find auxiliary references, which is also not implemented. But for types, that's just gonna be all the fields and methods inside that type. So that's gonna return those, and it will try to match them. Whenever it finds an exclusive match, since we already know there is like we are comparing types that have already matched before. So in there we like find the methods and we match them here. If they're the same, we match them. Then afterwards we're gonna like recurse here. So for instance, when we match a method here, we're gonna also try to see if we can find auxiliary matches, so extra matches for this method. And in case of the methods, that's useful because methods have instruction bodies which reference to other like fields and types and all that stuff. So basically we're gonna like recursively try to find all the types this way. And that's as far as I got. So that's not gonna find everything, but it's gonna find a lot. And then afterwards we can have a UI where you can match the ones that haven't been matched automatically yet. So yeah. The thing is, right now I just need to implement more boring stuff because I already have this match candidate thing everywhere, right? Like for instance, to match a type, you're gonna check all the nested stuff. See if they're like just recurs on the fields and stuff and blah blah blah. Same for method, this is all implemented. But I don't have match with, which returns a confidence, or get auxiliary references. Although I do know for fields, the only reference I'm going to return is actually the type of the field. So I can return that, and then that's fields type. Yes. Except that's the def, so I don't know. I only want to return if it's an actual def, so def. Yes, I prefer to work with software that actually works right now. Try to get type def. All right. Alright, that's good. So it's gonna try to resolve this as a type def. No, it's gonna try to turn it into a type def, and then if it is one, we can return it. Otherwise, actually it's a yield return. Yeah. So there you go. As works, yes, but I don't appreciate all the hidden features that haven't been fixed yet. So also I know the endlib and I know how it works, so I don't have to spend half my time learning Asm Resolver. Shit, that's not me. Okay, so is the type? No. Term. That's return type. Okay. I can always port it to Asm Resolver later if I want. It would be great if Discord would just work, but it doesn't. Okay. So that's for properties and fields. That's easy. We just return the type because that's the only thing we can really spider down with, right? Like the type of the field. We can find like all the reference to that type, but that's easier to just do inside method. Okay, now we have type reference. Let's see. No, type reference. Type reference is just like any kind of type signature. So that can be like internal, external, and a correlate type. So internal is like the binary you're matching. External is like a library dependency. And correlate is like the standard library. Okay, so method type. I think type is easier for now. So let's see. So I'm not gonna return itself, but so I can return all the fields and stuff. Field. Okay. Oh. Is that possible? No. It shouldn't be. But I'm gonna assume it won't be null. Yeah. Properties. And then methods as well, I guess. So that's methods. Now, is there? I wonder if there's any importance in the order. So if I do fields, it's gonna try to match the fields first. Whenever we, so this in the auxiliary reference, I don't think the order matters actually, because we don't do anything that depends on whether or not something is already matched. We only spider if it's not already matched, and that's just a direct recursion. So that should be fine. Order shouldn't matter. Speed-wise as well. Actually, I think... Now, speed-wise, it's not gonna matter either. Okay. Probably. And we also nested types, of course. So... nested types. Okay, that should work. Should I just do like this? Because that at least works and is clear. So nah, there. Okay, and then we have our method. So for methods, we can return all the parameter values as well, parameter types. I don't know if it's going to be immediately useful. Oh, that's another thing. Hold on. So if I return parameter types, it's going to go to the match collection here. It's going to get the references. Oh, I actually should return twice, shouldn't I? Maybe. So the thing with auxiliary references is basically you get two lists and you're gonna try to find exclusive matches between them. So if I open Paint, that's the proper tool. So you have your list of like things, right? So let's say these first three are your oh, I forgot a box. Oh. There. So these first three are, say, your parameters. So that's just gonna be type definition. So basically, it's meant to be like this, right? So we're gonna basically this one's gonna match to that one. That's gonna match to that one. If they match to like multiple ones, we're just gonna ignore them and act as if they're useless, right? Then also we should check if they're matched already. Do I already do that? So find exclusive matches and if the first one is already matched. So in here, in exclusive matches, I should also check if it's already matched. That's probably... Yeah, I'll look into that later. But basically, so, and then we have like these other boxes are basically like field references and type references inside a method body. So normally you're just gonna have like everything matches the other thing, right? But it's possible that over a version change in your binary, some control flow changes, and basically, for instance, this one is in reverse. So that it matches this way. That's also possible. Otherwise, it would just like basically assume the first one is the same as that first one, second one that second one, and etc. But that's not possible, so that's why we find exclusive matches. Basically. Now the problem is if we have like a type here that matches this, that's going to be really annoying. That should mean that one matches that as well. Which means we also need to... No. There. Means we need to disregard all those, which is annoying. Because we want as many matches as possible. I don't really know if I'm making much sense, but whatever. The fuck is stick bugging? But yeah, basically find matches, blah blah. So that's this. So that's why in here, so I need to return both the types and everything inside the method body, the parameters and everything inside the method body, which should be okay. Yeah. If it's a problem, I can always try to fix it later. Cause I'll notice, like currently my match percentage is like, I don't have it open anymore. Let's see. Like currently, I already matched like almost 70% 1-to-1. I don't know if they're perfect matches because I haven't implemented like perfect, like the confidence matching yet, but they seemed fine. I don't have it open anymore. Oh well. What's this? Ah, that's the bug thing. Okay. Okay, so I'm gonna return the parameters. Okay. Let me check Discord if it's still alive. Seems to be working. Maybe Cloudflare recovered. Who knows? Okay, so let's see. So we have our type. No, the unlib type. The unlib def. So that's our method. We have parameters. And then I think I can just return so that includes return type and this type. I don't know about this type if I want to return that, because that's already part of the parent. But it's not gonna hurt because it's gonna match. It's already matched, so it doesn't matter. But I want the type signature and then try to get type def. Okay. No. No. Oops. If come on. There we go. So that's parameters. That's all good. Now we can get a method body. Not everything has a method body, of course. So lib body. Okay, so the easy way is just to check if the operand of the instruction is a type def, a type ref, type def, a method def, an event def, anything like that, or a sig, I guess. So that should it should work. I don't think it's that bad for performance. It's certainly faster to check the operand, the opcode first, because that's a very cheap thing to do, and checking types is harder. I'm not sure how expensive it is, but if it shows up in a profiler, I can switch it. I can fix it. Because I'm gonna profile this anyway. Actually, I can do this easier, right? If I look at this dnlibdef, that comes from... Yeah, it's an idnlibdef, so I can just check. Yeah, I can just return everything that's an idnlibdef. That's easy. Instruction.operand is nope. Now I don't think there's, this also has assembly def and module def and generic param. I don't want to pass those, but I don't know how often they occur. I think I should probably check for them manually. Generic param or def is module def or def is assembly def. probably want to reverse this. It's a bit ugly. Ah, it should work. Okay. Yeah, that's clean enough. Hello, hello, water. Okay, so we're gonna get all the references from the method body, so that's all the from the method, so that's all the parameters, and everything that's in an instruction as an operand. I don't know if this actually gets hit, because it could be that everything is a type sig. I know we need to check, but should be okay. What's this inferior West? What's that inferior spelling of inferior? Hello, Washi. Yeah, that should be okay. This can be a link query. What kind of link query? That's awful. I love it. Let's not do that though. Washi being Washi, yeah. I mean, to be fair, Linux is nice for development, but not .NET development. Okay, I want to test this, but the problem is I'm gonna hit this first. So I just can't test this code yet, unless I do some manual test cases. Minecraft works and everything, yeah, but Minecraft isn't .NET development. But yeah, Minecraft runs pretty well on Linux, yeah, like really well. Probably better than Windows. I don't know actually. What are we coding today? So, hold on, I'm gonna show the thing again. Let's see, GitHub, Fabric, Matcher. So Fabric is like Forge. It's like a Minecraft modding framework. They have this thing called Matcher, which basically tracks symbol names across obfuscated binaries of the game. So if you make a full source map for one version of the game, like I think Forge does, I'm not sure how Forge does it, but you basically rename everything manually inside the version of Minecraft. And then whenever it updates, you just carry those names over. But to do that, you have to figure out which old classes match to the new classes. And that's what this does. And that allows them to have, I think it was Loom? No, not Loom. Yarn. Allows them to have mappings for like every version of the game they want, including snapshots. BindDiff, never heard of it. Could be. Oh, BinDiff. No, BinDiff is like checking the diff between a binary, but basically I'm just trying to find, like, if you obfuscate a binary twice, just basically map the names, which should be the same or something, if that makes sense. Yeah. Yeah. Like, for instance, this is an example of mapping for Minecraft. Like, they have this name, so net Minecraft class, whatever. They named it Bootstrap, like net Minecraft Bootstrap, and they have this field. They named it initialized. So for the next Minecraft version, they want to figure out what this field was, and this field, and this field, and this class and stuff. So yeah, there you go. That's basically it. Porting names from one version to another. For instance, if you reverse engineered a VM like Obfuscator or any other .NET VM, and you fully named it, and then you get a new sample, something's different, you will have to name everything again. Oh, does it? I didn't know it had a plugin. That's cool. That's basically what it is then, yeah. Exactly. So that's what I'm making. I'll go over the working again real quick. You just make two modules, you load them, and you do a lot of generic abuse. Hold on, let's see. So you make your match collection. You find initial matches by just literally finding the exact same types. And and that gives you like, I think it was 67% will have like exactly one match. Some of them will have no matches because they change between compilations, and some of them will have multiple matches in case it's something like an enum whose members have been removed. So they're basically empty types. So those will have many matches. Actually, I have the stats. Hold on. Yes. If I open Notepad, there you go. Yes, that's the RuneScape fonts. Thanks for asking. So basically, when I tested it, had like 0 of them, and 7% had what? Maybe I what? Anyway, yeah, like 7% had like no matches, 23% had multiple matches, so that's like types, like enums with no members anymore, and then like 67% it found one match, which is perfect. Actually, I can test it right now as well. So this is 2 versions of a game. Let's see. Boop, boop, boop. Oh, it's not printing. Why? Oh, because this version can't anymore because it needs this implementation. But yeah, it worked alright for a quick match. And it takes like, I think it was 0.2 seconds to do the initial quick matching to find the same types, even though it's like O n squared. But yeah, that's what this does. It finds unmatched types from 1 that are top level, matches them against every... Oh yeah, finds all top level types in first binary, matches against all other top level types, finds which ones are like perfect matches. If there's only one match, but we check that by just getting 2 move nets. If there's only one match, great, we add it to our registry. Otherwise, we don't. That's basically this. Oh yeah, it also does another check. It checks how confident it is, and I haven't implemented that yet. And then afterwards, it does auxiliary matches. So basically, say you have like a method. No, first of all, it only does types at first, and then for every type is going to return in this auxiliary matches thing, it's going to return like all the members of it, like methods, fields, nested types, and all that. And it's going to go here and it's going to basically recurse for all of those and see if there's any auxiliary types in there. For instance, for a field, it's going to be the type of the field. For a method, it's going to be its signature types and every reference inside that method. So that means if you match a method, it will also basically spider down, and it will compare the references in both methods from both binaries. And if there's an exclusive match, so I closed my paint thing, but if there's an exclusive match, like one type in one method matches to exactly one type in the other method, it's going to assume it's a match if it matches, and it's going to add that as well. So that way you should spider down and solve all the multiple references one, which was like 23%. So that means there's only going to be the 7% left, hopefully the 7% left that had no matches. And for that, I'm just going to like check against other types and see how confident you are they're the same and all that. But we'll get to that when we get to that. So right now I'm just implementing the boring stuff, like checking how confident we are that 2 things are the same. So I already have this thing, like is match candidate, which is just a very quick check. Just checks are the field attributes the same and is the type maybe the same. This is also a very simple check. It literally just sees like, are they both corelib types? Then compare them. Are they both from a library? Then compare them. Otherwise, it's true. And here I would implement a check where it would compare the actual type, but I haven't gotten to that yet. So that's a very simple check, and it's gonna have a lot of false positives, but hopefully no false negative. Wait, no, it's gonna have a lot of false positives, but hopefully no false negatives. Yeah. But this method, this match with method, should basically just return how confident they are, and which is just like an integer that's scaled with like a... Is that logarithm? No, it's power of 0.9. I mean, it's just like a number that says how many mistakes are there in the comparison. So that's kind of not quite sure how I do that for a field now that I think of it. Because I can't check how confident we are that the types are the same. Because, well, we can check other stuff like the attributes. So we can XOR those attributes and see how many bits are 1, which will be the bits that are different. I don't know if there's a count once thing in C#. I think it was on Rosetta code though. Let me see. No? Okay. No, count 1 bits. Oh yeah, there was a really cool function for this. Yeah, this one. This is so cool. Okay. It's probably fine to copy this. Let's see. Sounds like Binder, but for .NET. Yeah, basically. It already exists for Java, and I really want it for .NET. I haven't looked at any others for inspiration, because I only know about Matcher, which is for Java. And that code is like, first of all, it's Java, and second of all, it's like kind of hard to understand for me. Or I just didn't look in the right places, that's also possible. Let's see. So XOR of 0 and 0 is 0. Pretty sure, yeah. Exactly. Yeah. Count once of an int. Whoops. I'm not a fan of this. Oh, what's that? Ah. This isn't a very nice way of doing it. Is there like a prettier version of this algorithm? There has to be. Count 0. No, count once in int. Come on, give me like a pretty version. Fuck. Come on. Oh. We can use like the directly like intrinsic. Oh, that would be funny. That would be like really fast as well. Oh, let's not do that though. Come on. Okay, it's taking too long. I'm gonna go with this. So what's that doing? Shifting and checking with 5. If I change that to binary, that's just, yep. Same for these others probably. Yeah, they're all bit patterns. Yeah. So they basically just do like a bunch of bit shift math to figure out how many ones there are. Okay, cool. So basically now we're gonna compare those two enums, field attributes. And that's just a normal enum, I'm pretty sure. That's a ushort enum. I'm checking an int, but it's 0, so I can just 0 extend the ushort and that should be fine. Field attributes with other field attributes. So that's the difference between those attributes, and then I can do count once actually in match utils. So that's one thing. Like every time there's something that doesn't match between the attributes, and the attributes are actually like anything about like, is it private, is it internal, is it, I don't know, static, not static, is the pinvoke. So for every one of those, I'm gonna increase the confidence. There's a fine. Okay, look, there. It's not doing anything. Like it keeps coming back up. I don't know why. It just keeps popping back up. I think it's turning it off again or something. Yeah. Oh well, zeros. That's not zeros. It's ones. So, okay, how do I do confidence? Gonna make a static factory type thing. Public static. New. That's awful. No, let's not call it new. Yeah, let's just use a constructor. Okay, there we go. Okay. That's the ones. You only notice now? Been playing the entire time. It's pretty quiet though, and every time I talk, it's gonna talk. So I don't know if I should change that. Okay, so what else can I check? I assume the type. The thing is, I'd have this maybe equal, but I don't have like a match with, so I can't really return a confidence from this. Maybe that would be handy if this returned the confidence value. But that being said, like I think the confidence we have now is already pretty okay. So, confidence decrease. Like this should be okay, right? This is basically useless already because it just checks, is it a different kind, right? So there's two things this checks. First of all, is the kind of the type different? So yeah, core lib type, external, internal. If that's different, we can already assume it's not going to be the same thing, and we can increase or decrease the confidence by like 3 or something, or 2. But if it's not the same signature and it's external, that could be because the external type changed, which isn't an indication that it's different so much. But then that's kind of not common anyway. Another thing I can do is just, if it's not a match candidate, that would also work. If I don't know if this is a good thing, but it's something at least. Like if it's not a match candidate and we're checking a matchable field. Oh wait, that's recursion. Whoops. I meant to check the parent type, which I can't do because, hold on. Yeah, this is useless. I need to check the parent type, which I can't get right now because I don't have something global, or I don't have like dependency injection where it would inject the registries from the collection thing here. Like these registries, all they do is just they hold all the matches and unmatched things, So there's one per type, right? So you have one for fields, one for methods. Oh, that's the text message. No, it's not. Never mind. So this would be useful to pass down, but I don't know. I guess I'll just add a to-do maybe. Inject. Oh well, should be okay. So that's the confidence for this. And then we have methods. That's more complicated. Properties are easier. I'm gonna copy this for property first. The only thing with properties is that you need to get the first of all, property attributes, yes. Oh, I can just copy paste. Nice. That's done. Types. Confidence in types. That's a bit more complicated. Like I would have to the first thing I would do to reduce confidence, like if there's a difference in the amount of fields, properties, methods, or types, that's something significant. That's something I would make a reduced confidence for. So I would do confidence decrease. Hold on. So like this, right? So that checks the difference in amount of properties and decreases the confidence by that amount. Let's just and that's methods. I should probably do constructors as well. Like do them separately maybe. That would be, yeah, probably be better. Inner types. Does it expose if it's a constructor? No, I think. Oh, I have the genlib def. Why am I not using this? What is it? Why do I keep getting messages? Okay, so that's an easy check. Is it a constructor or not? Which I don't even need to do. I can just do it directly from there. That would work as well. Telegram. Okay, so where was I? Here. So instead of checking the methods, the amount of difference in methods, I want to do both constructors and non-constructors separately. So that in case like you have two types, one with one constructor, one with one method, they would have decreasing confidence here. So just being more thorough. So I would non-constructor methods, which would be a property, and then constructor methods, or constructors maybe. Yeah, that should work. There we go. Oh, you can also look at method semantics, getter and setters of properties. Distinct from normal methods as well. Oh, are they not counted in these? That's something I could do, yeah. Hold on. So I thought they were part of like the properties themselves, but I don't know how obfuscators deal with that because you can just detach them. Yeah, matching properties and events. It would make sense to check the method, but I don't. To be honest, I don't really know how property methods are handled. And also, is it different between obfuscated and unobfuscated? Because if they are part of the property, getter and setters are normal methods like constructors. Yeah. But are they attached to properties? Because properties are like, why do properties exist? They're basically just a field, like two methods that back a field. So like, I'm confused. Because like an obfuscator would just remove all traces of properties. Binds into properties, well. Oh, you can't always remove them. Really? I thought I saw it. Or it's just Jens by being bad at recognizing properties. Oh, well, yeah, but if you worry about like serialization and reflection, many obfuscators don't. But to be fair, I'm doing this for something that's obfuscated by EasyScaler, which is like a commercial one, so it will have to take care of that. So I guess it would make sense to check properties. So get method, wait, get methods? Can I have multiple? How do you have multiple getters? Oh god. Usually don't. Alright. Well, it makes sense to check, I guess. So if we're in property right now, so we can use the getters and setters. I'm gonna assume there's only one, because otherwise I'm never gonna be. So I can check if both of them have a getter and setter. That's something I can do easily. But usually the common case is having both a getter and a setter, or just a getter, I guess. But other than that, I don't know what I could. I guess the properties of the method. It has to have only one. Okay. Why would the CLR support multiple then? That's just strange. Is no. So that's one thing. That's a simple one, right? Yeah, technically, yeah. Alright, so we can check if they both have a getter and if they both have a setter. That's easy enough. I'm out of. Okay, I still have drinks. Good. So that's one thing. Now I can check the attributes as well, but that's only if they both exist, and that's a lot of code. Alright, so if that's null and that's null. Wait, no, I have an idea. Okay, so if get method is not null. Alright, so that means there is one. Then if other.dd.shin is null, there. Now else if, now we can do the XOR of the attributes, which I'm just going to inline. Up. No. Attributes. And that's count. There, it needs to be cast, of course. Okay, that's long. I don't like this. Maybe I should make this an extension method. Yes. Please be. Oh. You know what? I can live with this. Okay. So, if the first one is if the first one exists, then and the second one exists, we do this, right? I'm gonna increase this. Swap this. So if they both exist and this, if the first one exists and the second one does not, we do this. Otherwise, else if other get method. So the first one is null and the second one is not null. There. There we go. Use some variables for that. Yeah, that would make sense because that's a lot of duplication. Okay, no. Yeah, no. Yes. No, that's the method, right? What? Oh, no. There you go. So getter is not null and the other getter is not null. Then we do this, which is fine if it's 0 because it won't do anything. Decrease. Can you remove that? Oh, you can. That's awful. Let's not remove that. Yeah, I'll copy this now then. And just replace all the getters and setters. Cool. Wait, you can like inline this construct. No. If I do this, should I do this? That's kind of neat. It's shorter. I don't know if it's. Also, I can like do this as well then, right? That's gonna be really bad. Nope. Can't I? Would have to another. Okay, whatever. So I'm gonna just keep it like this. That's simple. Okay, so there you go. They both exist. Cool. No, I think that's all I'm gonna check for the getters and setters. I could check that. No, the type is gonna be the same because that's already checked here. So that's all good. Although I will move this up here. Oh, why do I do it skip method again? That's already done. Okay. Alright, that's property. I don't think I can do this for field, so that's all good. Alright, back to this methods. The types, no. I don't think I'm gonna check getters and setters here. I think I will check the individual types. Yeah. Because if I'm gonna basically try to match types based on their confidence, I'm gonna just sum the confidence of all their members, I think, or sum the uncertainty of the members, and work based on that maybe. Get the average or something, yeah. So I can do that on method compare then. So compare the fields and stuff, the length of it. I don't know if I should do more for types. Because types on themselves don't have much properties, except maybe their visibility and generics. Oh, I'm not checking generics either, am I? Ah, that's true. Maybe I should add that. Okay, generics. I'm gonna check the length of the generics as well. I'm not gonna check their respective like properties and stuff, but that's at least better than before. So now generics are checked as well. I think that should be okay. Oh, the type attributes. They have their own attributes, don't they? Yeah. I'm not checking that yet. I'm gonna yoink one of these. Yes. Okay. I think that's fine for now. That should be fine. So I think I have all of them then. So that's type. No, I don't have method yet, do I? Yeah, I need method still. I am checking non-generic What are non-generic parameters on a type? You mean like what it inherits? Like the base types? I'm not checking base types either, to be fair. I think. Maybe I should add those two. I need base type and then like interfaces too. Alright. So base type, I can turn that into a type reference here. So type reference is like a simple internal external check right now. I think that's a better thing. Oh. Wait, where is this set? Oh, itself, okay. Okay, and then we have the base type. So basically I'm gonna check if the base type matches, I think. This can't possibly be null. Because here we check if this is null. If they're both not the same. If they're different, then we return false. So they're either both null or both not null. And here we check if this is not null, then this, we know this can't be null either, because it's the same as this. So this is bullshit. Yeah. There we go. So that's an extra check again. Adding a lot of checks. I'm gonna like get a lot less single matches out this way, I think, which isn't fantastic, but yeah. Okay, so I'm not using the base type for confidence. I can try to get the confidence of the base type if I know it's a type def, but that would require knowing the registry, which I don't. Although I can do this, right? So that's interfaces. Also, I'm not checking interfaces here yet. Fuck. So, whoops. Because I'm not turning interfaces into type whatevers. Change that to, hold on. Does this please work? No? Okay, but how do I get a signature? This thing. Okay. To Ray. There we go. Okay, interfaces. These are now lint. And here can do is maybe equal. Although that's the problem is it's not sorted. So this is bad. Because if the order is different, it's not gonna match anymore. That's true. I need to check exclusive matches again. I had my exclusive. Hold on. This is kind of a bad method, I think it is. No, I can probably extract this into a helper method. What the fuck? Okay, that should work. So that's fine single. Now I can... Huh? Oh, then return. Oh no, I need to check if that's... Okay, and then out for I'm gonna set it to default here. Please work, come on. Okay, cool, that's nullable. And then the problem is that it needs to know if it's a class or not. The problem is if I do that, it's gonna complain here because this is not guaranteed to be a class. Which is the generic hell I was in yesterday. That's first of all, out x. I think that was continue. I don't remember what this was. Continue, yeah, okay. Otherwise return x here. I'm just gonna cheat the type system and say this null is not a null, even though it is, because nullable reference types and generics, if you do this, then you need to specify if this is a class or not, this t, which I cannot guarantee because this could be a struct, which means it cannot be nullable, and this would be a nullable t instead, like nullable. It would become this, which is different from just a t with a type annotation that it may be null. So that's why I'm just cheating here and saying like this null is not a null. Don't complain. That's what I'm gonna do. So that means this does not have a proper check. Wait, it does. Oh. Okay, it knows it may not be null. That's good, I guess. Oh yeah, because I hear. Okay. Because if I remove this, it's still... Okay, I don't know anymore, whatever. So, this is fine single, so I can move this now into match utils and reuse this. Make this public, make this internal. Okay, and this is match utils.find single. Now I also need find exclusive matches to be right. Never mind. I'm gonna need to re-implement this probably. That's annoying. So I want to reuse this find exclusive matches thing, which is basically you have two lists and it wants to make sure that every item from one list matches to one item from the other list, which I need here because fucking phone. Because I am checking here these interfaces, right? but their order could be different, and I can't sort them because there's no way to like have the same sorting. So essentially, either I throw this all away or I re-implement this find exclusive matches. If I want to re-implement it, I would need to abstract this away into an action parameter. No, not an action, a what's it called? A func. So I think it's easier to just make an overload for exclusive matches, yeah. So I'm gonna turn that into this here. So this is a func which takes, or is that a predicate? Oh, that's something that comes in. So I have two inputs, right? So I have I matchable twice, and it returns a bool. So that is my predicate. It's not technically a predicate because a predicate only takes one input, but shh, don't tell Washi. I don't know if Washi cares actually, but whatever. He knows more of this stuff than me, so that's why he may care. Where can I just pass in the predicates? No. Yeah, that still works good. Okay, so now I can duplicate this. So the overload that I was using, and I just pass in this predicate. Yeah. Except I need to like this, I think. So mf1 is the t. So I'm gonna turn this around then. I don't care about the direction, it's symmetrical anyway. So this should work. And then I can remove the predicate here. There we go, okay. Wonder if I can, no I can't, because generics. But now I can, should I make this generic? No, it needs to be, I'm gonna keep it like this because that's easy, but in here I can make it generic. See? And then it should work. Yes. Does this need to be a list? I don't think it does. Oh, because we're doing multiple enumerations of this, okay. Alright, so that should all be fine. Now I can also public move this into match utils. Okay, cool. Abstraction done. So this is specific for iMatchable because it has its own matchable implementation. Abstracts away to this, where it can work on anything as long as you give it a predicate. That's good. That's real good. I'm gonna take a drink again real quick. Okay. So I was working on this, so now interfaces, right? We need to try to match all of them. So I would do match utils. Oops, utils. Find exclusive matches, and it's gonna return to me a list of the exclusive matches. So that's a tuple of the source and the target. This ref1, ref2, and I'm gonna return ref1 dot maybe equal ref2. The problem is, yeah, because currently maybe equal will almost always return true because it's always going to be this thing, kind of internal is true. So I really need to implement this. It's gonna help a lot. Anyway. Dot counts. There you go. So it tries to find the matches between these with this predicate and counts them. So if now this is maybe a little bit, no, it's maybe equal, so it's going to be more likely to return true than false. Like false positives are fine because it's maybe equal. So this should be okay for a quick match, for like the match candidate. I guess, I hope. I'm gonna move it down because I think this is quite a bit slower than the rest. And order matters because we're hoping for a quick exit here. So we first do like an int compare because that's the fastest thing. Then do these lengths, which are just shouldn't be that hard. I hope that doesn't iterate. Probably doesn't. But yeah. Okay. We're finally done with this. Although I could probably do this as well. Yeah, maybe. There we go. Although the thing is, we already check here. So if there's a different amount of interfaces, it's gonna go down drastically. But that should be okay. Because you will have like maybe a mismatch here as well. Okay. Good. Finally done with type, I hope. So the method now. What things can be different? First of all, of course, what are they called? The attributes. That's an easy check. I like this check. Okay. Then it's a method, so we're already checking with this we check like public, private, static, all that stuff. So I guess the types we can check. We can also check what's inside the method body. Like check if there's a difference between the auxiliary references. I don't know if that's a good idea. First of all, if we directly call this, it's gonna cause a probably gonna cause a stack overflow because we have recursion maybe. Because get auxiliary references is used by match collection, which also Like, I don't know, maybe it's gonna cause a problem. I don't know for sure. Just to be sure, I won't do this. Actually, it shouldn't cause a problem, but okay. I can turn these into 2 different methods. That could be useful, so I can reuse them. Yeah. Okay, no, it's not useful for parameters. I don't. Not quite sure. I guess, yeah, I guess I'm gonna do the exclusive reference thing again. Exclusive matches between the parameters. I think that's the best way to go about this for now. So this will be parameters, and then exclusive matches, which is this thing. Now parameters are type references, so that's all good. Oh, it's not gonna be exclusive because it's gonna return true. I just realized if this returns true too much, it's not gonna be exclusive, so it's gonna drop the confidence. So I want to find unmatched instead of exclusive. That's, yes, that's a problem. How would I go about that then? So the same except for type single, I'm gonna use just any or like more than one. So just this basically. No, it's actually, no, it's just return this and this. So basically that's what you do to check if there's multiple. That should be the good way. Yeah, cool, has multiple. And instead of a tuple here, I'm just going to return the ones where we have multiple matches, which technically isn't required. We just need to return integer because that's our use case right now, just the amount. But it's not much more expensive, I think. And in case I need to use it in the future, it'd be nice. So, whoa, no. Okay, has multiple. So this can be an extension method. Same for this. So find single. There, and then there we go. There. Okay. So if it does not have multiple, we continue. Because we need multiple. Oh, one or multiple. So actually this would be where matches. Any matches. Then I don't need multiple. What am I doing? I just need any. Yeah, I just need to find if there's any match. Where any matches. Why am I overcomplicating things? Ah, fuck you. Okay. Where was I? Type reference? No. Method, okay. So find... No. Whoops. Where any matches between those two. And that's just going to be parameters. And I just want... Oh, that's the combination of references and attributes. Why did I do that? Ref1 dot reference and ref1 dot attributes equals ref2 dot attributes. Okay, cool. It's gonna be massive, so it needs to like this maybe. Okay. So now I can finally add this. Why did I call it interface? No, it is matched. Okay, parameters. No, parameter order is the same. What am I doing? I don't need this. I can just check by looping. But then if there's not the same length. What's the best way to compare those? These are probably fine. Because the problem here is if you have like two methods, so you have method which int and I don't know, bool, which gets changed into int bool string. So this is gonna give a problem here with confidence, right? With like your parameter length being different, because they are different, right? So you're gonna decrease confidence here, and then this is gonna completely just, this is gonna be random, because in this case there will be matched parameters for everything, so these will match perfectly. So it will not take the string into account. If you did it the other way around, it would. So this is actually a pretty bad check. However, no, I'm just gonna if there, I'm just gonna put it in here so I don't have to deal with the, like, if there's a difference in parameter length, this could either do nothing or do too much. So I'm just only gonna do it if the parameter length is the same, even if it's gonna be a higher confidence overall with parameter length differences. So it'll be fine. Return confidence. I think I'm finally done then with all the match width stuff. I think. So that means I can check. First of all, let me see if there are any to-dos left. Or any big ones. Aha. Wait. No, I just did this, didn't I? Would want amount and... Okay, where? Yeah, okay, good. So I can get rid of this. And then in here, that's all good. Okay. Sure. Auxiliary matches. Yeah, this should be okay. Now, one thing I want to do is in here, find initial matches. I want to check how many things get dropped because of this. So I'm gonna add a count dropped. Count. Okay. So I can just have another stat I can use. It's a value tuple, so it shouldn't be like a problem. Even if it's a normal tuple. Whatever. There's no problem that I add extra turn things. Else. Okay, cool. So I can add an extra stat now. No, that's for the total matches, right? No. Okay. So whenever I dropping something because it's unconfident means that in here, this does not like work. So instead of account 1, it becomes account 0. Oh yeah, that means I need to... Okay. That should be correct. So if I run this now, this shouldn't crash anymore. Fingers crossed. Haha. That's a null value. That's not good. Why is that null? Okay, yeah, that makes sense. I should have checked that. Because this is already nullable. I think I declared it nullable, yeah, but I didn't actually add my null check. Let's see now. Oh. Oh. Oh shit, it didn't crash. Okay, that's real good. First of all, let's compare the oh, no drop because of unconfident? None of them. That's good. Although, haha, this increased to 0 match percent. That's not great. So this is what I had before. And then is this now? So basically, we have more 0% zero match cases. Hi, I'm your fan. Hi, fan. You're not working hard enough. I'm too hot in here. So our single match is down, multiple matches down, and 0 matches up. Why is that? Because we added more things. Added more checks in our code. But that should be okay. Because there's still, it's not a massive increase. It's like 2% in 0 matches. So from 7.5 to 9.5. And this is still the overwhelming majority, which is important. And later we can, after we do the auxiliary matches, I can like do the rest based on confidence and stuff. So that's really good. It didn't crash, that's something. Now I'm gonna print out 0 match percent. Oh wait, I'm gonna change these stats so I can also see the amount, real amount. Come on. Okay. Good, and then 0, and then there we go. What am I doing? I'm making a matcher, which is like apparently like bindiff for Ida and Ghidra, basically mapping over symbol names from one binary to the other, assuming they're both obfuscated and they have different names because of that. For instance, example, Minecraft obfuscates their symbol names. So version 1.16 has one kind of name, like one set of names. 1.16.1 will have other names, and they will be randomized. So you will try to map over the names you came up with for 1.16 to 1.16.1 without doing everything manually from scratch again. That's basically what I'm doing, but for .NET. Let's see, so that's the matches for first stage. What does that return? Nothing. Something private static void print stage to stats, and I'm gonna take in the entire match collection. So I'll just print out stats from those. Also, there's type matches and there's like method matches and property matches. So I need to check all of those. Yeah. So type matches. So that's collection.types.matches.count. Right, and then the second one is this divided by Jesus Christ, this is slow. Unmatched source.count. I think I should just make this a local function. That's a parameter. Whoops. Oops. Uh-oh. Okay. No. I want to abstract this so bad because if I copy this, it's ugly. So void that's no, I'm not doing that because that has generics and generics are awful. I'd rather just yeah, there we go. This is going to be properties. Yeah. That's all of them for now, except types in the future, events in the future. But that's not for now. Okay. Alright, so one thing I also want to check is, do I lose anything? Because if I add a match, I remove them from the unmatched source and add them to the matches. But I want to make sure that I don't accidentally like forget to remove something, because that would be a bug, and bugs are not good. So I'm gonna... I think I already print the amount of types, right? Oh, actually, yeah, I can check that manually. Okay, run. We're gonna run it in release, so I know the performance as well. Ah, that's not bad. That's not bad. So creating the match collection is like 0.8 seconds because I'm looping through all the types and saving them. Find initial matches, 0.2 seconds. That's really good. Really good. 0%. What? Oh, floats. Right. Hold on. Let's run that again. Yeah, there we go. Okay. Oh, that's not many matches. I mean, it matches a lot of them, to be fair. Like, that's 8,000 matches for methods. That's really nice. If you look at this, the amount of single matches here is like 6, 7. That's actually lower now. Wait, what the fuck? No, this went up. Huh? Okay, I'm gonna breakpoint there. I want to see what is actually happening. Oh, no. That needs to be debugged. Okay. Yeah. That's strange. Okay. So, should I? Yeah. Okay. So, collection. Let's check our types here. So we have 900 unmatched and a lot of matched. This should be... Like, it suddenly became more. Like we have more types than we had before. Because we started out with, how many types? Oh, first of all, let me... there, I'm gonna move that over and then... Because we start out with like 1500. Oh, but that's top level types. That's not like the nested types. Like state machines, that's why. Okay. Oh, fields. Ah, all right, I can check. No, I can't because there's no string. Yeah, well. Ah, look, it figured it out. Oh, that's cool. If you look at key and value, they both have the same name. Like it actually figured out the correct thing. Oh, that's so cool. It's actually working. And it's fast. It doesn't take like a minute to run. That's also really cool. Okay, I'm gonna real quick implement a toString then, so I can more easily check if all of them are correct or not. Project. So I can do toString or I can do debug view. I think debug. What's it? Fuck. Debugger display. Wait, visualizing? What's this? Ah, cool. Oh, display. Yeah, there you go. And a name of, I think it's tnlibdev. Okay, now I'm gonna do that to iMatchable. And I hope that's gonna mean it applies to everything that implements it. Ha, never mind. Nope. So matchable type. That's annoying, but I can live with it. Method. Field. Okay, so that should basically use the unlibdef as the debugger display. So if I now debug it again, Okay, now I open the collection. Ta-da-da-da. Wait, hold on. Inspect. Oh, come on. Oh, I need to open them one by one. But hey, they are the same. No, this one isn't. Huh? Oh, that one is different. It's the wrong match, damn it. No, unless those names are actually random as well. That's possible because it's a field name, right? So it's part of ESOScater. So I'm gonna go down here, and these are the ones from the actual game, which were decoded, and they actually look the same to me. That's awesome. Whew. Wow. Hey, it works first try. How's that? Let me check the types as well. So that's just fields. Like I can do methods as well. Let's open something up. Yeah, coins overlay, constructor, buy more. Yeah. But everything that is matched is correct, right? Like even like these names are the same. That's strange. Let me double check that they're actually in the same. Well, I can't check if they're different binaries, can I? I'd have to check the assembly. Like declaring type. Assembly? No. Module. Okay, so can I have the path here? Location or something? Yeah, location. So that's 322. So that's 3097. And then module. .3091. Yeah, so there are actually types from different assemblies. So I didn't just have a bug where I added the same type to both key and value. Oh, nice. Oh, that's so cool. Okay. Okay, enough me geeking out about my own thing. I'm just gonna double check types real quick, but they should also be correct. Whoop. So non-client regions, command targets. Yes, they're all correct. That's actually awesome. I want to check how many have a different name. Right? Because I know the ease ones are different, but like I'm gonna ignore the ease ones. Yeah. Actually, if I only check types, it should be fine. Yeah, okay. I'm gonna see if I can write that, if I can print that real quick. 0p, so that means printing with what's it called? Percent as formatter. I want matches where no counts, but where keep the pair dot. Oops, come on. Key dot name is not equal to the value. And it's gonna divide it by the total matches. Yeah, total matches. It would make sense. All right, let's print that out. So I can just see, like, are my names correct? 0.24%. See, that's actually not bad. Although I'm curious about which ones they are. So I'm gonna print them out as well. So change this to where. Oops. For each this, can I deconstruct it? Yes. No, 0, 1. That's key dot the end of dev dot name. Oops. Value. Okay, so I'm gonna just print out all of them that are not the same. So I can get a general lead. They're probably gonna be state machines and the like. Yeah, okay, this makes sense. Like this is randomly generated. This is also random. It's like a key for Skater. And these just seem like garbage. I don't know which ones they are. To be sure, I will also just quickly check. Yeah, so that's the key. And then that's random Skater garbage. Which is probably the same. I don't know. It could be they just randomized the names. But yeah, perfect. They probably randomized the names. Oh, this is cool. Okay, so now we have a bunch of them left over, right? Like as I printed, I'm gonna just print it real quick again. So there's a bunch of matches that are... Okay, let me see, copy all this. Boop, copy, put it in Notepad. So, let me remove all the time stuff as well. Boop. So that's type, that's top level types, blah, blah, blah. So that's the same as before here. That shouldn't be the same, should it? Oh, it didn't change that. Okay, whatever. So 63% of types are matched. There's a lot of them that haven't been matched yet, and I can probably compare them. Like, that's fast. Thank you, EC. Editator. Sorry, I'll call you by that name, Editator. It's pretty, yeah, I mean, compared to what someone else did, their code took like, I think it was a minute or something, or 2 minutes to do their matching. Okay, EC, good. I'll call you EC then. They took like 2 minutes or something, or a minute. And I don't think their matches were pretty good either. But mine are, like, all of them are spot on, which is, oh, I'm so happy about that. Now properties, well, let's see, so I'm not matching everything, right? So I can do a third step where I just check if there's anything else where there's good confidence. Yeah. The thing is, once I match all the types, I can match the fields. So for instance, if I have 2 fields that match, I can know their parent type is the same as well. So that's something I can still do. Didn't that make person? You mean Jan? Yeah, it was Jan. So if 2 fields are matched, or 2 properties, or 2 methods, I can take their parent and match them as well. That's something I can do. I don't know if it's gonna work, or if it's actually gonna have any impact, because I think that's already all done. But I can give that a try. So yeah. Oh yeah, you see, the reason I'm making this is because Chan took too long and he never released anything. So I don't know if he finished it or not, but well, I need it, so I'm making it. So I'm gonna see, I'm gonna do match parents then, I think I'm gonna call it. So match parents. Oh yeah, also here I'm doing a lot of stuff manually. Like I'm loading 2 assemblies, I am making a match collection, doing the matches and stuff. This is all gonna be inside of, hold on, wait for it. Inside this, except this should take strings probably, but okay. So it's like one method you call, and the rest is gonna be like this constructor and stuff is all gonna be internal. But I'm making it public so I can do all my speed testing in here. like my time profiling. Profiling, quote unquote. It's not really profiling, it's just checking how long stuff takes. Like, oh, that's too long, I need to fix it, you know. So, great method. So I have this, that's find initial matches, find auxiliary matches. I have that twice. And then this goes here. So I need to pee actually, but I'm gonna take like a 1 minute break and I'll do a toilet break and I'll be back in like, well, 1 minute. So, yes, be right back. Taking my phone. All right. So apparently my dinner is ready, so I won't be able to continue the stream right now. But I think I'll come back after I'm done having dinner. So I'll come back then. Probably continue stream. Gonna commit this first real quick. Oop. Let's see. Implement let me double check. So here I added more stats, which is all good. Yeah. I don't think I really did much health. Yeah, okay, so I'm gonna commit this then. Boop, yeah, should be fine. All right, I'm gonna go have dinner then. I'll be back in like probably an hour at most, and I'll post about my stream in the same places as usual. So yeah, see ya.